Math is actually broken. There are truths that can never be proved. There must be God. AI can never surpass humans. These are exaggerated and even wrong. Let's clear up 7 common myths about Gödel's Incompleteness Theorem.
1. The incompleteness theorem means math is broken. From there, people often jump to this. So math can't really be trusted. But hold on, in mathematics, the word complete doesn't mean perfect. A system is called complete if every true statement can be proved within that system. So the incompleteness theorem was showing that, in short, mathematics always contains true statements that are unprovable. Same word, completely different meaning. 2. The incompleteness theorem is basically the mathematical version of the uncertainty principle. Both are famous. The names sound so similar, but they're talking about completely different things. The incompleteness theorem says, in any consistent and sufficiently powerful mathematical system, not every true statement can be proved. It asks, what cannot be proved? The uncertainty principle asks, what cannot be measured precisely? The more precisely we measure a particle's position, the less precisely we can measure its momentum, and vice versa. Don't be fooled by the similar names. 3. There are truths that can never be proved. Some people even go further. Something can never be proved. Maybe that's God. The incompleteness theorem proved the existence of God. But that's not what the theorem actually says. It says only this. Within a formal system, some true statements are unprovable. The key words are within that system. If we move to a stronger system, by adding more axioms, that true statement may become provable. So the incompleteness theorem wasn't saying that truth is forever beyond human knowledge. It was describing the limits of a particular mathematical system. 4. Gödel's incompleteness theorem is just a word game. It has nothing to do with actual mathematics. This statement is unprovable. At first, it doesn't feel like real mathematics. It sounds more like a clever paradox. But Godel found a way to turn that paradox into a rigorous mathematical statement. It became just as much a part of mathematics as 1 + 1 = 2. That was Gödel's real breakthrough. The result had a major impact on mathematics itself. And later, mathematicians even found genuine examples of the kind of statements that the theorem had predicted. 5. Every system is incomplete. You'll hear this all the time. But no, not every system. The incompleteness theorem applies only to mathematical systems that are powerful enough to express basic arithmetic. Even within mathematics, there are systems where the theorem doesn't apply, so you can't automatically use the incompleteness theorem to explain companies, society, relationships, or life in general. The theorem has very specific conditions. 6. Mathematics and logic failed. Yes, Gödel's incompleteness theorem revealed a limit of mathematics, but knowing your limits isn't defeat. It's a sign that mathematics has taken another step forward by recognizing its own limits. The theorem reflects its continuous growth and enduring success. 7. Humans are fundamentally beyond AI. This idea is surprisingly popular. The argument goes like this. AI is a formal system. Formal systems have limits. Humans can recognize those limits, so humans must be something more. Sounds convincing. But whether human thought is a formal process or something fundamentally different is still an open question in philosophy, logic, and AI research. The incompleteness theorem didn't settle that debate. It made that debate even more interesting. The incompleteness theorem reshaped how we understand mathematics, computer science, logic, philosophy, and even the way we think about intelligence itself. That's exactly why it's been misunderstood so often. So over the next few videos, we'll explore Gödel's incompleteness theorem, simply, enjoyably, and above all, accurately.